Hello there. Welcome to CXC Math TV. And today we're going through the Applied Mathematics Unit 1, Paper 1. I'm going to try to make more of these videos doing Applied Math and Inti Math and Keep Unit 2. I'm going to try to make one a day, at least one a day. That's the aim from here. All right. So Applied Unit 1, let's get right into it. This is from 2020. Of course, I'll try to do the other years, starting from 2016, come up to 2022. Also, if you want access to these paper ones, whether Applied, Pure, or Intimath, you can download them from the Wix site. Go to the Wix site. I'll leave a link in the description. You know the drill. Before we start, guys, please just like and subscribe, all right? If you find the video beneficial at the end, just like, all right, and subscribe. Please, it really helps. All right, so let's get started. The first question, it says, which of the following is correct for negatively skewed distribution? So I have to remember for negative skewed, what does negative skewed mean? Remember the formula for skewness? The formula for skewness is mean minus mode. And negative would mean that that worked out to be less than 0. So the mean is going to be what? Less than the mode. The next formula is mean minus median multiplied by 3. This is the next formula for skewness and it's less than 0. In this case, the mean is less than the median. All right, so in this case, the mean is less than the median, which is less than the mode. And so that is when it is negatively skewed, where the mean is less than the median, which also in turn is going to be less than the mode, which is option A right there. All right, and if you don't like it that way, you can also think about the graph when it's negatively skewed, something like this. All right, where this would be the mean bar x, and then the middle of the data set, 50% is right there is the median. Then the part with the highest frequency, that is your mode. All right, so something like that helps, but we don't want to spend too much time on these easy questions. Let's move right along. It's not scrolling down for me. Uh, all right, number two. Number two, it says, what is the mode of the data set? So first thing, mode is the one that occurs most frequently. Frequently, we notice 6 what? Number of matches, right? By the way, first identify what is X and what is Y. It says, item 2 refers to the following table, which shows the number of goals scored by a football team in 20 matches. All right, so number of goals is 0, 1, 2, 3, 4. So yes. So notice 6, the number of goals 2 get scored 6 times. So if you were to actually list them out, you have 3 matches where no goal is scored. Then you have 5 matches where 1 goal is scored. Alright, and then you have 6 matches, 2 goal is scored. Alright, so the modal number of goals is 2. Alright, and it corresponds to that number, the highest frequency. Easy. Number 3, it says a regional organization is made up of 8 regions. The CEO of the organization wants to get persons' opinions about changes to be made in the organization. To do this, he takes a sample from 5 regions. And from those regions in the sample, he takes a further sample from 10 persons from each region. This method of sampling is referred to as cluster. So you notice once you see 5 regions, 5 different regions, it's either cluster or stratified. But stratified is when we put it into strata, and it's really more a random sampling technique. All right. When it's kind of less random, then it's a cluster. All right. So that's number 3. Pretty straightforward, easy so far. Number 4, a sampling frame. That's just definition. A sampling frame is just a list from which a sample is drawn. So that would be option B. Very easy. Very easy. This is applied math, unit 1. Lovely. Number 5, it says for All right, let me make myself smaller. Why am I so large? All right. And so number 5, it says for a population divided into strata, under which condition is it preferable to use stratified random rather than simple random? So we use stratified when we're doing random sampling, but we want to look at, I'm going to give you an example. Let's say I want to look at how fitness affects individuals in in real life, right? And maybe I have 200 people. I can randomly select 200 people, but fitness is going to vary. So I could break them up into categories, maybe 0 to 19, 20 to 29, and 30 to 39, and so forth. Instead of just randomly taking 200 people, which would come from any class, I can maybe take 40 from this group, 40 from this one, 40 from this one, 40 from the age 40 to 49, and then 40 from 50 and above, right? So notice what did I do? I did what? I picked individuals. Individuals in each strata are what? Different. So when do we use stratified? When the individuals in each strata are different. Different in this case by what? Age. So it's still random, but we're going to use stratified random sampling. I hope that kind of make it clear of when you use stratified as opposed to just random sampling. This one want the median class. All you need to do first is create a column and write cumulative frequency. So cumulative frequency. So this is 3, add 3 to 5, 8, 8 to 8, 16, add 10 to that, that's 26. Add 26 to 18, that's 44. Add 44 to 12, that's 56, and then this is 60. Now, the median class is going to be half of n plus 1. Half of n plus 1 is half of 60 plus 1. So half of 61 is 30.5 position. Now, 30.5 is going to lie in this class. All right, so in this class, you notice this would be the 27th to the 44th term. So in that class, it's going to lie in between 24 to 26. Easy. I'm going to pick up the pace a bit now because, we're going a little slow and I think it's fairly straightforward so far. Item 7. It says, how many students score higher than 70 marks? So you go to your cumulative and you go up from 70. So I'm going up. We are going up. Going up together. We go up and this is 100. How many get more than 70 marks? It would be the rest. So the 120 minus 100 is 20. 20 right there. So 20 students got more than 70 marks. 20 students got more than 70 marks. Look which one that is. That's option A. Nice. Moving right along. Question 8 give us a box plot, or we call it a box and whisker plot. Remember, interquartile range is equal to the upper quartile minus the lower quartile, or some people like to say Q3 minus Q1. Upper quartile is 12, the lower quartile is 6. 12 minus 6 equals 6. And that's option D. Nice. Question 9, another cumulative frequency graph. Another one, right? So now it says the number of students who collected more than $30. So all we do is go to 30, 15, 20, 25, 30. Here is 30. We go up. And that point, I don't like how they give us this point this time. That looks like, for me, I'm guessing this is 35 from my extrapolation. And they wanted how many students got more than $30. So we're going to have to do the subtraction again. So 60 minus 35, which is 25. That's that. 25. Option C. Very easy. Lovely. Question 10, it gives us a histogram and it says the class that contains the median. Now, first thing you have to find the median class, right? Now, first thing, add up the frequencies. This looks like 11. No, scratch that. This is not 11. This looks like past 12 and a half, so that's 13 right here. Looking at this scale, this right here is 7.5, so this would be 8. This would be going up. This is 15. This is one less than, so that's 7. Right here looks like 2. This looks like 3. This looks like 1, and this looks like 1. So the total frequency is 13, 21, 21 and 15, 36, 43, 45, 48, 49, 50. So the total frequency is equal to 50, right? So the median class is going to be half of 50 plus 1, which is the 25.5 position. 25.5 would lie where? 13 and 8 is 21. And so 21 plus 15 is 36. 36. So this would have from the 22nd to the 36. So the median class is here, 20 to 30. That one took a bit of work, 22 to 36. So in that case, it's in between 20 and 30. That's the median class. Easy. Also the modal class if that asks. Another box plot. It says the distribution. Now, if you shade over here, that part is larger, and so we say it is positively skewed, all right? So if you shade over the next side, if you had drawn and it looked like this, and you shade over here, then it would have been negatively skewed. So it's positively skewed. We move on. That is straightforward and easy, and we are loving it. Now, students, remember, this question right here, it says a random sample of 4 numbers that lie between 0 and 5. Inclusive is to be selected. Numbers are given correct to 2 decimal places using table 4. So I'm going to show you. This is this formula sheet that they give you. This is table 4, right? It's going to be on page 5. And let's go back to the question they say. Let's say using table 4, we need to write down the answers, right? So using table 4, beginning at the 11th row from the top, I'm going to count down 11 rows. 1, well, this is 5 rows. 5, this is another 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is the 11th row from the top, 11th row. And then they say that we should go to the second column, 1, 2, this is the second column. So this is the point we're at. And then now they say, what are the resulting numbers after 2.43? No problem. So this is 2.43. That's the first number. Let's change the color. The second number is going to be continuing 4.42. So notice I'm using different colors to show you it. It's 2.43, then 4.42. Use a different color now. Now the next number is going to be the 006. That's 0.06. And using another color, the last one would be 8.72. Very easy using the random number table. So looking for that option, and here it is, option A. It's so easy. It's so easy. It is so easy. Number 13, they want the mean age of children, and they tell you it's 200 students, right? So you know that the sum of F already, the total here is 200. Now you need to have your X. Your X is the midpoint. Between 5 and 7 is 6, between 8 and 10 is 9, and between 11 and 13 is 12. It's not writing so well, why not? 1, 2. Between 14 and 16 is 15. Between 17 and 19 is 18. Remember the formula for mean is the sum of fx over the sum of f. So in that case now we're just going to just put it in the calculator. So you put what in the calculator? The x value times the f. So 6 times 26 plus 9 times 42 plus 12 times 64 plus 15 times 52 plus 18 times 16 divided by 200. Now I cannot work this out in the interest of time. I can, but let's just put it in the calculator, please. Put it in your calculator. So I bring out my calculator and fraction. 6 times 26 plus 9 times 42 plus 12 times 64 plus 15 times 52 plus 18 times 16 divided by 200. Put that in the calculator and we get 11.85 is the mean. That's option A. Alright, moving right along. Number 14, a 10% trim the mean. To find a 10% trim the mean, first thing, find the total frequency. If we add them up, that's 20, 30, 37, and 3 is 40. And we need 10% less of that. 10% less of 10% of 40. 10% of 40, I believe that's 4, right? 0.1 times 40 is 4. So that means we're now looking at 36 of the data. So remember, you're going to remove now. We'll remove 2 from the left. So remove 2 from the left and the right. So if we remove 2 from the left and the right, then this frequency actually become 2 from this side. I'll make this frequency become 3. And 2 from this side, let this frequency become 1. So now we can find the new mean using that. So this is now fx, so it's 3 times 1 plus 15 times 2 plus 10 times 3 plus 7 times 4 plus 1 times 5 divided by the sum of f now, remember, is 36 because we took out 4 of them. Voila, 2.67 because we were getting 8 over 3, 2.67, option B. Well, 2.66, that's what they have. Okay. Number 15, it says a pie chart with radius 8 centimeters is drawn. Using 6 centimeters the radius of outlet A. So the radius of outlet A, and notice outlet A, if you add them up, this total is 10, 17, 26, 36. So notice 6 units or 6 centimeter corresponds to 36. And a pie chart with radius 8 is drawn for the third outlet C. Alright. Then they want the total sales for C. So following this, right, 6 go to 36, then if 6 go to 36, then of course we know 8 and then go to what? 64. That's straightforward. We know this is just the square of it. So that's easy. It's no problem. Alright, that's straightforward. Number 16. Oh, we're at module 2. Alright, so module 2 deals with probability and the distribution techniques like binomial and normal distribution. Module 1 was just introduction to statistics. So all we did was mean, mode, median. So measures of location and measures of spread. That's what we did in module 1. So now 16, probability between -1 and 1. So these probabilities between -1 and 1, we add them since it's inclusive of it. Inclusive of -1 and 1. So we add these three. 0.2 plus 0.1 plus 0.3 is 0.6. Now we're at normal distribution. I love normal distribution so much. I just think it's so nice and entertaining to use the table. So now we want given that x follows a normal distribution with mean 24, and this is saying the variance is 36, so the standard deviation is 6. First thing we need to do is standardize this. So z is greater than, remember the formula is x minus the mean divided by the standard deviation. So it is 25 minus the mean 24 over the standard deviation 6. So that is, wait. Oh, that's just 1 over 6. I'm so embarrassed to put in that. 1 over 6. Now, the probability z is greater than 1 over 6 is the same as 1 minus the probability z is less than 1 over 6, which is 0.167. So now this is what we work out. So we look in the normal table for the probability z is less than or equal to 0.167. So now we go to our normal table. I have the normal table here. Now this is not the one you'll see in the exam. You're going to use the one from the CAPE. All right. Practice using the CAPE one. I took one off from Google. Practice using this one that you'll see in the exam. I'm looking for 0.16. 0.16 is this number right here. See it here, 0.1. Second number 0.16. This is 0.5636. All right. So that's if you use 0.16. But some might say, but sir, why not use 0.17, right? You're absolutely right because 0.17 is where you'd round this off to. So just for safety, let's use 0.17. All right, but I want to use 0.16, all right, because I noticed that so far they haven't been rounding off. So in that case, it's 0.5636, and then now this is now 1 minus 0.5636, and when I do my subtraction, 1 minus 0.5636, I get 0.4364. 0.4364. Now I notice that is not there. And you notice these two are close. That means they did some rounding off. So that means, oh man, that means our answer is not there. So they did the rounding off of using 0.17. So let's do the round off. We'll make the adjustments. I'm sorry about that, guys. I'm sorry. We're just having fun. Let's use 0.17. So we're going to look in the table at 0.17. Because they can't expect us to get exactly 0.167 because our table won't give us that. So unless we're going to have to do some averaging, so we don't want to do that. So this is what our table would give, and then we'd subtract that from 1. So change it to 5675, and that is this amount, 0.4325. Now look at this. That answer is also not there. Wow, that answer is not there. So now you're going to wonder, how are we going to extrapolate our answer? This is how you'd extrapolate your answer. You have what we call the distractor. The distractor would be what they're expecting you to get in the table. What you're expected to get in the table is this. So that's the number that you'd actually subtract from 1. So notice from our table, we get 0.536 for 0.16, and for 0.17 we get 0.5675. But the number in between, which is 1 over 6 is a 0.167, this would be the number in between those two answers we get. Then we'll subtract it from 1. So this is the distractor, so this is the correct answer. I'm sorry I took so long to just do that. All right, I know you want me to hurry and go as fast as I can. Now this right here is the CDF. I call it CDF, cumulative distributive function. So from the CDF, always generate now the PDF, the probability density function. So the PDF now, this is the probability of Y. This one is 0.37. Then you'd subtract it out, you get 0.21. Then subtract it out, you get 0.22. Then subtract it out, you get 0.2. So now they want the probability of 3. Using our PDF now, it's 0.22. We're done. Easy. Lovely. Number 19, it says A and B are mutually exclusive. So always draw your little Venn diagram. Mutually exclusive mean they don't intersect. So this is A and this is B. And they're telling us that the probability of A is 0.2, the probability of B is 0.1. So on the outside is 0.7. And then they say find the probability of A union B complement. Where is A? This is A. Where is B complement? This is B complement. We are shading. So now, what is that? Just 0.2 plus the 0.7, which is 0.9. Option D. Sweet. And we finish. Now, this question says, when a normal distribution is used, an approximation of the binomial distribution is. So remember, the binomial can be approximated and Key things now. This right here, less than or equal to. All right, so remember, when you approximate from normal, when the normal is used as an approximation of the binomial, remember the binomial is discrete values, all right? So this is gonna, if it's less than or equal to 45 with the binomial, we can go up to 45.5. All right, so it's less than 45.5. Now, if it's strictly greater than 40, this is what? 40.5. If it's strictly greater, this is 40.5 is our start region. All right, so it's 40.5 to 45.5. Option C. All right, does that make sense? I really hope it makes sense. What we're saying is, remember, 40 is a discrete value. All right, 40 is a discrete value. The next discrete value would be 41. But for a continuous data set, 40.5 go upwards would round off to roughly the 41. All right, so since we're converting from discrete to continuous, it's really 40.5 we start at. And the last one is 45.5. I really hope that makes sense because we're going from discrete to continuous. Number 21, a scatter plot shows negative. It needs to go down. That's negative. Going down. So which one is going down? This is going up. So it has to just be option A. That's the best one. Option A. Number 22. Now the formula for this would be phi of the second value, phi of -1 minus phi of -3. But this is now 1 minus phi of 1. And then this is now minus in bracket 1 minus phi of 3. Yep. Then now when you subtract 1 minus 1, cancel each other, right? So phi of -1 minus phi of -3, 1 minus phi of 1, 1 minus phi of 3, 1 minus 1 cancel. Then this becomes minus phi of 1. Then minus and minus let it become plus phi of 3. So this is now just phi of 3 minus phi of 1. That's just basic algebra. Option B. Cannot get any easier. Number 23, the probability of L. To find the probability of L, notice it can be the probability of L, it can be the probability of B, it can be the probability of B intersect L, plus it can be the probability of A intersect L. That gives you the probability of L. So it is just going to be 0.6 times 0.25 plus 0.4 times 0.48. And we bring out our machinery, the calculator, and put it in 0.6 times 0.25 plus 0.4 times 0.48, which is this amount, 0.342, option B. Sweet. Now they want the probability of L prime given B. This is given by the probability of L prime intersect B over the probability of B using conditional probability formula. Now L prime intersect B, we look at L prime and B occurring at the same time. L prime and B, so L prime and B, we have to go up. This is L prime and this is B, and this would be 0.75. And it's so easy now because this is now just 0.75, 0.6 times 0.75 over the probability of B, which is 0.6, and these cancel, so we'll just get 0.75. And this happens because they are independent events, but that is something else for us to talk about. Talk about that soon. Number 25, it says, if the letters of the word school are arranged at random, what's the probability that the arrangements begin with OO? So if it begin with OO, 1, 2, 3, 4, 5, 6. There are 6 letters in school. Any letter can start it, that's 6. The next, any one of the 5 next, any one of the 4, any one of the 3, any one of the 2, any one of the 1. So the total possibility is 6 factorial, which is 120. Now, starting with O, to start with O and O, that means one of the O must be at the front, then the next O right here. But then any other of the four letters can come here. Any one of the four here, any one of the three here, any one of the two here, and the last letter here. This is then 2 times 1 times 4 factorial, and 2 times 4 factorial. Remember, 4 factorial. If you don't even want to do it, you can just put in a calculator. Why am I doing that? Put this in a calculator. 6 with the exclamation mark. 6 factorial 120. 2 times 4 factorial is 48. So the answer is 48 divided by your 1. You really can't bother to work it out. And 48 divided by 120. 2 over 5. What? Let's go again. And I'm not even, you notice we're doing it full and no edits, no nothing. You actually seen me and we're working the paper together smooth. Let's look at where we went off. 1, 2, 3, 4, 5, 6. They said that it should begin with, what is the probability that it begins with OO? Any one of the two come here, one come here, 4 letters remain. And we worked out our 2 times our 4 factorial. We had our 6 factorial there. 6 factorial. Isn't 6 factorial 120? 6 factorial. I'm so sorry, guys. 6 factorial is 720. My mistake. It's evening. I'm a little bit hungry. And so I do apologize for these mistakes, all right? Make sure when you do the exam, you're not hungry, okay? So when you're hungry, you tend to make these mistakes. 1 over 15 B. All right. Number 26. It says now we need to find the expected value of x. Expected value of x when it's a binomial distribution, the formula is n times p. Alright, now we don't know what is n, but they gave us some context clues to find n. They told us the probability of x when it is 0 is this amount. So in other words, we need to set this formula equal this number. Remember, the probability of x equals 0. The formula is n choose x, p to the x, 1 minus p to the n minus x equals 0.1296. N is how much? We don't know, so we'll put back n. Choose x. X is how much? 0. The probability is what? 0.4. To the what? X. X is 0. Then 1 minus 0.4 is 0.6. To the n minus x. N minus 0 is n equals 0.1296. Now n choose 0. You have to remember, look at this. 5 choose 0 is what? 1. 10 choose 0 is going to be what? 1. 10 choose 0 is 1. 20 choose 0 is also what? 20 choose 0 going to be 1. So this part is 1, so we get 1 times anything to 0 power is 1 times 0.6 to the n. Give us this number 0.1296. Now we're going to log both sides to find n. Yes, logs is in this topic here. Now we have 0.6 to the n equals 0.1296. So in that case now, n log 0. Come on, pen. Okay, guys, please. I need to plug in my computer. All right. Don't shut off, please. Just wait on me. I have to plug in the computer, else it's gonna shut off. All right. And as I said, students, I promise I'll make the next set of videos a little bit better. I'm just trying to go for one a day. These things do happen. All right. So again, we're at this point, and now we just need to log both sides. I want to change the color ink. Please allow me to. Good. So now n log 0.6 equal the log of 0.1296. So n is just equal to log 0.1296 over the log of 0.6. Put that in your calculator. Fraction button. Log 0.1296 divided by the log of 0.6. And we'll get n. N is 4. So now that we get n equal 4, now we can use this formula. Remember, the aim was to use this from day one. So now we can use that formula and say the expected value of x is equal to 4 times 0.4. And we'll put that in the calculator. 4 times 0.4, which is 1.6. Option B. Alright, cool. 27. It says the heights of rose plants follow a normal distribution with mean 215 centimeters and a standard deviation of 20.2. And it says the probability to three significant figures at the height chosen is less than 200. So remember, x follows a normal distribution of mean. Remember, it's x follows normal distribution of mu comma sigma squared. So the mean is 215 and the standard deviation is 20.2. And then we square it, of course. Now, the probability then that x is going to be, the height is less than 200. We need to standardize it. So the probability z is less than 200 minus 215 over 20.2. You punch that into your calculator. So fraction button. 200 minus 250 over 20.2. And so what we're getting is negative 0.74. Remember, now you have to work out 1 minus the probability z is less than 0.74. It's equal to 1 minus, look in the table, 0.74. This is 0.7 and this is 4. Intersection is bam 0.77. So in that case, it's gonna be 1 minus 0.771, and that would be the 0.229. Lovely. Nice. Okay, that's 27. Now it says an unbiased tetrahedral die is rolled twice. Tetrahedral means there's only 4 sides. Okay, then why do they need to say all of that? What's the probability of getting a total score of 4? Now, I know it's embarrassing, but I like to use sample space when I'm doing this, alright? It's ridiculous, but 1, 2, 3, 4. 1, 2, 3, 4. It just feels easier for me. So one possibility is to get 1 on one die, 1 on the next. And then you can get 1 and 2, or you can get 1 and 3, or you can get 1 and 4, or you can get 2 and 1, 2 and 2, 2 and 3, 2 and 4, and we get the gist. Now, they say what's the probability of getting a total score of 4? To get 4 mean it could be the 1 and 3, or it could be the 2 and 2. I'm going to continue to see which other one give me that. This is the 3 and 1. This is now 3 and 2, 3 and 3, 3 and 4. This is another one that give me a score of 4. 4 and 1 is out, so this is 3 of them out of 16. Alright, there's 16 possibility. I didn't list out the rest of the 4s. And we're done. I know it's ridiculous I had to put the sample space to see it, but that's just me, alright? Maybe you can work it out mentally. I prefer the sample space. Now it says it is estimated that 30% of the population holds university degree. If 10 citizens of this country are drawn at random, find the probability that at least one of them holds a university degree. Always remember, once you get P and N, it is binomial distribution. Once you get P and N, it's binomial. So X follows a binomial distribution of 10, 0.3. I want the probability at least one of them hold a degree. So the probability X is greater than or equal to 1. This is then going to be 1 minus the probability X is less than 1. Alright? we need to find 1 minus the probability x is less than 1. In other words, we're going to find 1 minus the probability x equals 0. So is 1 minus the probability x equals 0. Remember, we to the binomial formula, write in red again. So it is NCX, n is 10, so 10, choose 0. P, in our case, P 0 0.3, 0 0.3 to the 0 times 0 0.7 to the 10. So 1 minus all of that, put it in the calculator. 1 minus, bracket, 10, choose 0, times 0 0.3 raised to the 0 power times 0 0.7 raised to the 10th power. Put that in and we get 0 0.972. 1 minus that is 0 0.972 and we finish. Easy, easy, easy. Nice. Number 30. Number 30, it says, in each round, the probability of a player win or lose, and the probability of winning the first round is P. So if winning the first round is P, the probability of winning the first round, they say, is P. So I mean the probability of losing the first round is 1 minus P. Now they say the probability of losing the second round, so the probability of losing the second round is 2 over 5. So I mean the probability of winning the second round would be 3 over 5 because they need to add to 1. So now it says, what is the probability of losing the first round? Losing the first round is this one. And at the same time winning the second round. So these two operate, but they're independent. So we do what? Since it says it's independent, we multiply them. 1 minus P times 3 over 5. And that's our answer. Easy. So we're looking for 1 minus P times 3 over 5. It is clearly option D. Now we move right along. We're in module 3 now, guys. Module 3. It says if the sample size n are drawn from a population which is not normal distribution, then the sampling distribution of the sample mean is approximately. No, it is normally distributed if n is greater than 30. So normally distribution when n is greater than 30. This is sampling distribution. See, that was so easy. Next one, in a z-test, it says at 5% significant level, at 5% significant level, the critical value is. Oh, so now we need to decide if it's a one-tail or two-tail test. This is a one-tail test. Since it's a one-tail test, our critical value is Z alpha. So Z alpha, which is Z 5%. So Z 0.05, 5%. And you actually get that. You go to the normal table right here. Go to your normal table. We're looking at 5%, so we should be 95% confident. And so we're looking when we see 0.95. We look in the table, when do we see 0.95? This is 0.9505, and this is 0.9495, so it'd be in between those two values. So this is 1.6, this is 1.645. That's what I'm getting. Average it to get 0.95. So we're at 1.645 from our table. All right. So that's when we'll be 95% sure. So 1.645, there it is. Easy. That's easy because it's a one-tail test. Now, it says if x is chi-square with 12 degrees of freedom, then the probability x is less than 4.404. Now, look in the chi-square table. So we're looking for 4.404. All right. So 4.404. This is t-test, chi-square. And how much degree of freedom? They said 12 degrees of freedom. This is 12 degrees of freedom. All right, this is our 12 degrees of freedom. And we need how much again? 4 point what? 4.404. So looking across, For here it is, 4.404, and that is, this p-value is 0.025. All right, but remember, all right, we have to remember, I like to always draw it. All right, so we get the p-value 0.025. All right, so which one is it? Is it this or is it this? So I like when we always picture it, right? Just draw a little graph, right? So if I draw my graph, right, looking something like this, all right, and we're looking at 4.404, somewhere here, 4.404. We want the probability is going to be less than this value. So the 5% really corresponds to, not 5%, the 0.025 corresponds to this small area. So therefore, probability x is going to be less than this is what? 0.975. Don't ever make that mistake and put 0.25 just because you saw it in the table. Okay? Please. Lovely. Now this one, it says a t-test. First thing, we'll always use a t-test when n is small, and small is considered less than 30. Alright, so when the sample size is less than 30, we use a t-test, and also we don't know what is the population standard deviation. So that's when we use t-test. So normally distributed. So a t-test is used when it is not normally distributed. Its population variance is unknown and the sample size is small. Option C. That was very easy, surprisingly. Alright. Sample size small is less than 30. That's so we consider it small. Number 35, it says a t-test is used whether a solar coil lasts on average 7 years. A sample of 10 of these solar coins has a mean life of 6.75 and the standard deviation is 0.5. The value of the test statistic, remember the test statistic T is equal to x bar minus the mean divided by the standard deviation divided by the square root of n. That's our test statistic. So the sample mean, what was the sample mean? A sample of 10 and the mean life was 6.75 minus, they said that it lasts on average 7 years, so mu is 7 over the standard deviation. The standard deviation given was 0.5 divided by the square root of n, and n is what? 10 years. And they just plug that in the calculator. It cannot be any easier. So 6.75 minus 7 over fraction button 0.5 over the square root of 10. So this is negative 1.58 is our test statistic, and we finish. Easy. Number 36. It says the item refers to the following contingency table. I can't bother read it. I really can't. Alright, I'm just gonna jump to the question. Alright. Does it give you everything really? Good weather, all of that stuff. Oh, it's a football match over 40 matches in good or bad weather. It says a chi-square test for independence is conducted on whether on the effect of the weather on the team's performance. The loss expected frequency for the number of lost in bad weather. So in bad weather, this is the loss in bad weather, this one. So now you have to remember this formula, the expected value. To find the expected value, it is the row total times the column total over the total. That's how we find expected value. So the row total in that one was 12 times the column total. The column total here was 23 divided by the total matches, which was 40. Alright, so just to show you the row total with loss in bad weather, this is the row total, the column total. That's how we get the 23 and the 12. Easy. Number 37, another t-test. Why so much t-test? So now it says a t-test was conducted at 5% significant level using a one-tail test. So if we're using a one-tail test at 5%, all right, so this is what we call the rejection region. Well, if it was hypothesis testing, it reject when z is greater than t. Um, this is 1, 2, 3, 4, 5, and we use n minus 1 degrees of freedom. All right, n minus 1 degrees of freedom. So 5 minus 1 is 4. All right, so we're looking at T4, and this is 5% significant level. All right, so that is, I know I should have write T here, all right, or that would be the rejection region, but this would also be our critical value. So we're looking in for T4 0.05, T4. 4 degrees of freedom. Here we go. 4 degrees of freedom. One tail test. So looking at 5%, which is 0.95. All right. This is it. And that is 2.132. 2.132 is here. Option B. Nice. That's our critical T value. Now it says, which of the following conditions are satisfied to use central limit theorem? We use central limit theorem when n is greater than or equal to 30. So the sample size is large. Remember, small is less than 30. And it's non-normally distributed, but we can approximate it to normally distributed. So the small sample size, no. The small are taken from the large sample size. Yes, this is it. All right. Option A. Number 39, it says now, they give us all of this and they tell us the chi-square test value is calculated, the critical region will be, we're going to have to read it. So the grades given by 3 teachers at a school are displayed in a 3 by 5 contingency table. So 3 different teachers, right? So let's say the 3 different teachers were row come before column. So I have the teacher's name, you have Mark, you have Tanisha, and you have beautiful Sade, right? Just a beautiful teacher Sade, Mark and Tanisha. And of course, they give their 5 tests, something like this, right? So teachers, and then of course this side show you the grades, right? So just want you to get an idea of what they're saying. And then now they say a chi-square at 5% is carried out to test the hypothesis that there's no association between the grades and the teachers, right? So our null hypothesis is that there is no difference, and our alternate is we beg to say, yes, there is a difference. If different teacher mark the paper, there's a difference. And they say now we need to find out the critical region. Remember, your critical region is the critical region. Oh, so let me set up the test first. All right, so first thing is, of course, you have to write down your test statistic. And your test statistic, your chi-square test statistic. First thing you have to work out the degrees of freedom. And the degrees of freedom is the we have 3 rows here, so 3 minus 1 times, right here it's going to be 5 minus 1. All right, so the degrees of freedom we're getting is 2 times 4, which is 8 degrees of freedom. So we're looking at 8 degrees of freedom for our chi-square value at, and this is at. Now this is a two-tail test, so we're looking at 5% significant level. We divide it by 2, that's 0.0. 5% divided by 2 is 0.025. All right, so this is what we're looking at now. So 8 degrees of freedom, 0.025. So let's go to our chi-square again. 8 degrees of freedom. Here is 8 degrees of freedom. I'm looking at 0.025. All right, and this is it. Or it's two-tail test. So another way is I want you to always understand two-tail test. All right, or your two-tail test can be, you're looking at this would be 0.975. This is, but we'll talk about this one a little later on. All right, so these are the two values to pay attention to, 2.18 and 17.53. So let us see which one they have. 2.18. We don't get 2.18. We don't have 2.18. All right, so this would be our critical region. I'm not getting 2.18. They have 2.73. All right, they have 2.73 here. Where did we go off? 3 minus 1 is 2, and 5 minus 1 is 4. And then we, of course, multiply them. That should give us our degrees of freedom. All right, and then, of course, we do our rejection region. This would be our rejection region. The rejection region, remember, is when our test statistic, if mod z, right, is greater than, if mod z is greater than z alpha over 2, and in our case we're not looking at normal distribution, we're looking at if z is greater than or chi-square value. So if chi-square calculated, we're looking at if that's greater than our chi-square value with 8 degrees of freedom, and that should be 0.025 because it's a two-tailed test. What I'm gonna do then is maybe let's see if it's with 0.05. All right, because chi-square is a little bit different. So 0.05. If I go 0.05, oh, 2 points. Okay, okay, okay. I see where I blundered. All right, I see where I blundered. Because with chi-square now, it's either that, we reject when chi-square is greater than that value, or when chi-square is going to be less than the 1 minus the alpha over 2. Okay, okay. So it's the chi-square greater than that one. The 2.73 is indeed correct. It was my error right there. So chi-square calculated is greater than 2.73. All right, 2.73. With chi-square, it's not like normal distribution. You don't need to divide it by 2. So you don't need to divide it by 2 for the critical region. My apologies, my apologies. All right, chi-square is a little different. Now that's 39. Question 40. The linear regression line y on x is, always linear regression line is to use to, let's see, to estimate y for a given value of x in a situation where the independent variable, where x is independent and y is that, yes, or it is used to estimate x, or we're not estimating x, that's crazy. Minimize the sum of the squares of the difference between no, what we use the regression line is to make some prediction. So all those options were crazy. We're trying to predict y. Now it says a chi-square test of independence is carried out using a contingent table with 4 rows and 5 columns. So first thing, right, work out your degrees of freedom. Remember, your degrees of freedom is n minus 1. This is for the rows times n minus 1 for the column, or some people like to say r minus 1 times c minus 1 for row times column. So 4 minus 1 is 3 times 5 minus 1 is 5 minus 1 is 4, and 3 times 4 is 12. So the degrees of freedom is 12, and this is at a 5% significant level. So we're looking at our chi-square with 12 degrees of freedom, and this is at 5% significant. So 12 degrees of freedom, 5% significance. This is 5.226. 5.226 is option A. Very, very easy. Now it says in hypothesis testing, the probability of committing a type 1 error is called. Now, what is our type 1 error? Remember, type 1 error is basically when the null hypothesis is rejected, given that this is when the null hypothesis is rejected, given that the null hypothesis is true. So the null hypothesis is rejected. So I always like when we get it, the idea of what it is. This is it. All right, so this is the normal distribution, right? And we're looking at, this is our mean, and we're looking at this critical region, right? These are our, this is our critical value, right? And we're doing our test, a two-tail test, and this should be, let's say this is our rejection region. This is the rejection region, right? And then HO right here is in here. And we shouldn't reject it, so, but we actually did reject it, right? HO is true, it's in here, and we reject it. When we actually reject it, what did we work out? All right, what we actually worked out then was the significance level. All right, the outside region there. That's all. That's a type 1 error. Question 43. Uh, so much reading. The weight of, can I skip and just go to this? I'm just gonna skip. Remember, it says confidence interval. Confidence interval is bar x plus or minus z alpha over 2 in brackets sigma over the square root of n. So bar x was what? The mean weight was 40.2. So this is 40.2 plus or minus z alpha over 2. It says 99% confidence interval. So if you subtract 1, there's a 1% chance of a mistake, 0.01. They will divide that by 2, and that is 0.005. So we're looking for z of 0.005. Z of 0.005. I'm just going to use my normal table to save time. Z of, well, my normal table. I'll use the applied math syllabus. Mine sometime is, so normal table, and we're looking for 0.005, or in other words, 0.99, wait, 1 minus 0.005 is 0.995. So looking for 0.995, 0.995. 0.995, 0.995 is somewhere here. This look like in between 2 point, this is what, 2.5051525354555657. So this is 2.57. This is 2.575. All right, so now I jump back over to the question. This is now 40.2 plus or minus 2.57 over standard deviation is 3.4 divided by the square root of n, and n is 35. So now the lower limit would be put in the calculator with the minus 40.2 minus 2.57 in bracket, fraction button, 34 over the square root of 35. Close the bracket. It's 25. Oh, I put 34. Sorry, guys. Sorry, this is 3.4. And so that's 38.7. Already we'll get the answer, option A. All right, that's it. And then the answer with the plus should be 41.7. See there, yes, correct. Now, number 44, the unbiased proportion for students who scored less than 20. Those who scored less than 70, 21, 2, 3, 4, 5, 6, 7, 8, only 8. And this is out of how much? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 8 out of 40, I'm seeing. And 8 divided by 40 is 20%. That's 0.200. Easy. Okay, last one. It says, what is the probability that the mean has 5 bags is more than 45? Okay, So in this case now, it's normally distributed. X is normally distributed, and mean mass 50, that's the mean, and the standard deviation 6. But remember, this is sigma square over n, and n is 5. So now we need to find out the probability that bar x is more than 45, greater than 45. So we need to standardize it. Remember, the standardized value is now bar x minus mu divided by sigma over the square root of n. So this is now bar x is 45 minus 50 over sigma, which is 6, over the square root of 5. Put that in the calculator for me, please, which is 45 minus 50 over 6 divided by the square root of 5. And we put that in the calculator and we get negative 1.86. So find the probability z is greater than negative 1.86, which is, this now is what? This is now the probability z is less than 1.86, right? And then you put that in. You put that in your normal table, or you go to your normal table, or we go to our normal table and we look for 1.86. Where's my normal table? Stop it. 1.86. 1.8 is here. 0.80, 81, 82, 83, 84, 85, 86 is 0.9686. So 0.9686 is 0.969. Finish. This was so easy. So guys, we finished the applied math unit 1. This is 2020. I'm gonna do 2016 up to 2022 for both paper 1 and paper 2. And I'm trying to do one paper per day. So if you see this paper today, the next one you should see tomorrow, and it continues. Now, if the content in terms of the specific topic you want to review, whether it's chi-square distribution, normal distribution, and all of that, I have a class recording that I upload here on YouTube, and you can just go and watch um, that entire topic and then come back to past papers. All right, make sure that you go through all of the topics thoroughly, and then the paper will be easier. All right, so with that being said, I hope this video was beneficial, and remember, hit the hit the subscribe button, hit the like button, please. It will do me a lot. Thanks for watching. Have a wonderful day.